Algebra students, you've been working on graphing linear inequalities, you've been working on systems of equations, so now we are going to jump into systems of linear inequalities. The only way you can solve a system of linear equations like the problem on the slide right now is to graph both and see where they overlap. So I'm going to use some different colored pens. Let's start with, let me go back, sorry. Something's going on. 1 second, there we are. All right, sorry about all that. So blue with this one, red with this one. All right, so let's graph the blue one. The blue one says y is greater than or equal to negative 3x minus 1. I go to negative 1. I use the slope of negative 3, down 3 over 1. Down 3 over 1, down 3 over 1, up 3, back 1, up 3, back 1, up 3, back 1. All right, solid line because of the equal sign. So now I'm going to try to draw a straight solid line through all of those points. 0, 0 is clearly not on the line. So I will check 0, 0. Is 0 greater than or equal to negative 1? Because 0 times negative 3, that just goes away. Yes, it is. So notice I'm not just going to start shading here. I'm going to put a little arrow here saying, hey, you're shading over on this side. Okay? Well, yeah, I'm just going to do a little arrow, and we'll come back to y in a second. All right, so we're shading on this side. Changing colors over here. Now we're in the red. Y is less than x plus 2, so I go up to 2, and then I graph a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, right? Pretty straightforward. Back 1, down 1, back 1, down 1, back 1. Good. Now, this is going to be a dotted line, so let's see if I can keep this going here. All right, dotted line. The best I can do on a computer tablet. Thank you. Sorry. Now plug in 0, 0. Is 0 less than 2? The answer is yes. So I shade over here. So the answer is all of this, and I'll shade it in yellow, where both shaded sections would overlap. All right? So if I had shaded everything here in blue, and I'd shaded everything here in red, do you see where the red and blue overlap is where the yellow is? So the answer is just the yellow part. Good? That's why I like the little arrows on the side here for me, so I shade at the end, but that's your answer. Don't forget to label your x and y axes. And that's it. That's all we're doing. So let's try another example. Take a minute, pause the video, try this one on your own, and unpause the video when you think you've got an answer. You should have some graph paper, try this on your own. All right, here we go. So x is greater than or equal to 0. Well, x equals 0 is just this line right here, and it's solid because it equals, and greater than 0 is over here. Y-axis, x-axis. Y is greater than 0. Well, that's just the x-axis. That's just this line right here. Here's where y is 0. Where is it greater than 0? Up here. So right now, if I just had to shade these two, it would be this upper right quadrant, the first quadrant. Now this one here is in standard form. Remember with standard form, did not mean to do that. We'll put those back in a second. But with standard form, you can kind of cover up 1 and say, 3y is equal to 24. So y equals 8. So I can go up here, 1, 2, 3, 4, 5, 6, 7, 8. And then instead of covering up the 4x, you could cover up the 3y, and you get 4x equals 24, so x equals 6. And we had 8 here, 1, 2, 3, 4, 5, 6, 7, 8. And I had 6 here. 1, 2, 3, 4, 5, 6. And now it's a solid line between those 2 points. Good? Now we shade. Check 0, 0. Is 0 plus 0 less than or equal to 24? It is, so we shade over here. So remember, we had the x-axis here, shading here. We had the y-axis here, shading above. And then we had this black line here, which is shading below, and the overlap of all three is just this triangular region. Good? All right. One more to try on your own. Take a second, pause the video, try this one. I will try not to erase in the process. Okay, I like this one because this is not going to be a very nice problem. The numbers just aren't nice here, but we'll make it work. So for the first one, solve for y. Y is greater than or equal to negative 7x. Plus 0, you could think. So that means a y-intercept of 0, which we haven't seen yet. I can't test 0, 0 for this function. Down 7, 1, 2, 3, 4, 5, 6, 7 over 1. Or up 7, back 1, 1, 2, 3, 4, 5, 6, 7, and back 1. Dotted line. I remember Philip in math the other day saying if it's greater than, shade above the line. If it's less than, shade below. That works. I still like testing a point like way out here, like 10, 0. So if I can, I'll test a point on an axis. That's when x is 10 and y is 0. Is 70, right, plugging in 10, plus 0 greater than 0? Yes, it is. So we're shading over here. Like Philip said, we're shading above the line. That works. Now, this one is a little tricky. I could solve for y. Okay, so I subtract 3x from both sides. Then I divide by negative 2. Don't forget to flip the inequality sign when you divide by a negative. And then what I get is just kind of a gross number, negative 5/2. So, granted, I've done a lot of math in my life. When I see 3 and 2, I'm thinking 1 and negative 1. Wouldn't that be on the line? 1 and then negative 1? See how I figured that out. 3 times 1 is 3. 2 times negative 1 is negative 2. 3 minus a negative 2 equals 5. So this point is on the line. And now that I have a nice point, I can just use the slope and go up 1, 2, 3 and over 2. Up 1, 2, 3 and over 2. Down 1, 2, 3 and back 2. It's a solid line because of the equals, and if I'm really good here, which I probably won't be on a computer, it will look like I hit the y-axis at about negative 2.5, right? Not so good, but there we are. Now I can check 0, 0 here, and if I plug in 0, 0 in the original, I get 0 minus 0 is less than 5. That is true, so I shade up above that line. So now, where's the answer to the system? The answer to the system is all this section in the middle where it overlaps. Good? That's above the blue line. That's above the yellow line. It's right in there. Good? All right. So, not too hard tomorrow for classwork. You're just going to be graphing 2 linear inequalities on the same axes and seeing where they overlap. If you have colored pencils, this is a fun unit to bring those in for. Another option, let me clear this off. Here we go. Another option is with these graphs. Some kids like to graph a line like this. We'll make it dotted because that was an accident. And then they shade everything in a certain direction. And then they graph another line, maybe not in a different color. And that other line here is like a solid line that looks like this. Ooh, that's tough, sorry. Not ideal. And then for that one, they shade, let's say, below the line. And so then they shade everything like this. and you get like a nice cross-check pattern in the area where they overlap. That was not the best hand-drawn example of the cross-check pattern. Some kids will get cool looking, checkers in there, but then they'll have a line here. Good. I think you get what I'm saying. Anyway, so your quiz tomorrow will have systems of equations. It'll have one system with 3 variables and 3 unknowns, and then it'll have one linear inequality that you have to graph, and then that's it. Just 2 topics, and then you'll move right into your classwork. All right, have a good night. Peace.